Okay, so now we're in chapter 3, and so we're going to talk about inverse functions. So in order to talk about inverse functions, we need to talk about one-to-one functions. So you'll be able to determine whether a function is one-to-one, also be able to find the inverse of a function, and determine the domain and range of an inverse function. All right, so let's look at the first section, identify one-to-one functions. All right, so what does it mean for a function to be one-to-one? Well, it has to pass the horizontal line test, so we'll talk about what that is. All right, so it says a function is one-to-one if every horizontal line test intersects the graph of f at most once. Otherwise, the function is not one-to-one. So this should look familiar to the vertical line test, right? We determine if something is a function if it passes the vertical line test. So if we have a vertical line, the line touches the function at most once. So that's how we know it's a function. To determine if it's a one-to-one function, we have to make sure it's a function even if we turn it sideways. So instead of turning our paper sideways, we do a horizontal line test, right? So we want to use a horizontal line test to see if the graph crosses my horizontal line at more than one point. So there are kind of two steps to this. One, we need to make sure it is a function. Maybe I don't want to say f of x because it could not be a function. So we'll say, is it a function? Does it pass the vertical line test? And then second, does it pass the horizontal line test? Okay, so let's look at the first graph. So it doesn't matter where I draw a horizontal line. It touches our graph only at one point. However, in the second one, drawing horizontal lines, in some places it's going to touch my graph more than once. So we say that this first graph is one-to-one, and the second one is not one-to-one. Okay, and so we can think about this the same way if our functions are listed differently. All right, so let's look at part A, determine whether the following functions are one-to-one. So this function is just the points 1, 4, 2, 3, negative 2, 3, and I can actually already tell that this is not one-to-one just by looking at these points. 2 goes with 3, but also negative 2 goes to 3. Every x value doesn't have its own y value. So I'll say, because we have 2, 3, and negative 2, 3, it's not one-to-one. But what if you didn't remember that? What if you didn't remember that rule? You can always just plot these on a graph and use the horizontal line test, right? So I'm just going to kind of sketch what these points would look like. Maybe like 1, 4 would be here, 2, 3 would be here, negative 2, 3 would be here. Does not pass the horizontal line test. Okay. All right, what about part B? F of x equals the square root of 5x. So there are also a couple ways you can look at this problem. So this is where it comes in handy to understand what functions look like and to know what those basic functions look like. Because we can know, oh, this is a square root function. It's going to look something like this. And yes, it does pass the horizontal line test. So yes, the graph of the square root of 5x is 1 to 1. However, what if you didn't remember the horizontal line test or you didn't remember what the graph looked like? You could also do it algebraically. All right, so algebraically, again, we want to show that each x value has its own y value. So the way we could write this out is that we need to show that if f of a equals f of b, then a equals b, right? We got to have the same x value if they're going to go with the y value. So the way we do that is we just find f of a, so square root of 5a, set it equal to f of b, which is the square root of 5b. This should say 5b. And we have to write that out. Try again. 5b. All right, and then we'll just solve. So we can square both sides, divide both sides by 5. Perfect, this is what we wanted. It's 1 to 1 because that means these two x values must have been the same. All right, let's look at x squared. All right, again, knowing what graphs look like will really help. X squared looks like this. Does this pass the horizontal line test? No, it does not. It does not pass the horizontal line test. Well, what does that tell us? That this function is not 1 to 1. I should put lines in between these. Okay? Or we could show it algebraically. Again, show that if f of a equals f of b, then a equals b. Show that these must have been the exact same x value. All right, so f of a is a squared. F of b is b squared. I'm going to take the square root of both of those. Oh, well, what's the square root of something? Plus or minus. Plus or minus a, plus or minus b. Well, what does that mean? So this could mean that a equals b, or a equals negative b. All right, so we get multiple answers here. So that means it's not 1 to 1. Okay, so this is how you figure out if a function is 1 to 1, both algebraically and graphically.